All right, let's go ahead and first practice these conversion problems. We're going to start with these first just because I think a couple of them might help with some of the problems that we're going to deal with above. And so first off, we want to write down our conversions that we have. We know that 1 kilo of anything is equal to 1,000 of that thing. We also know that 1 calorie is equal to 4.18 joules. And so we're going to use these to help us convert between things. And so this is 8.50 times 10 to the 2. That's the same thing as 850 calories. And we want to convert it to kilocalories. And so we're going to go from calories to kilocalories. We know that 1 kilo of anything is 1,000 of that thing. And that's going to give us 0.850. Now we're going to go from calories to joules. We have 444 calories. We need to then go from calories to joules. And according to the conversion above, 1 calorie is 4.18 joules. We just type that in our calculator. And you end up with 1,855. All right, the next one, we're just going from 1.8 kilojoules to joules. Very easy, 1.8 kilojoules. And we're going to go kilojoules to joules. 1 kilo of anything is 1,000 of that thing. And we end up with 1,800 joules. And then the last one here, we have kilojoules. And we somehow need to get to calories. But if you take a look at the top there, we don't have a conversion between kilojoules and calories. But we do have a conversion between kilojoules and joules. And then we can go joules to calories. So we need two fractions for this one. This is going to be 4.5 times 10 to the negative 1 kilojoules. And we're going to go kilojoules to joules. And then we're going to go joules to calories. Now we know 1 kilo of anything is 1,000 of that thing. We know that 1 calorie is 4.18 joules. All we do is type this in our calculator. And what you end up with is 107.65. With sig figs, it's technically 110 calories. All right, so let's go ahead and do some of these other practice problems. And so we have these practice problems here. We did learn this equation where Q equals MC delta T. And just a quick reminder, delta T is always going to be equal to the final temperature minus the initial temperature. Now, the specific heat of aluminum is 0.889. Okay, so that's the specific heat. Specific heat is C. How much energy is required? Okay, so it's asking for energy. And so energy is Q, that's what it's asking for, to raise the temperature of 15 grams of aluminum 18 degrees Celsius. Now, first off, what I want to point out is notice how, first off, we're raising the temperature. So that is a positive change in temperature. Now, it doesn't tell us the initial or final temperature, but that doesn't matter because this 18 degrees Celsius is the change in temperature. So it doesn't matter what the start or finish temperature is because the 18 is the change in temperature. And so this is really easy. You just plug it into the equation here. So we've got delta T, we've got the specific heat, and then we've got the mass right here. And what we end up with is Q is equal to the mass, which is 15.0, multiplied by the specific heat, 0.89, and then multiplied by delta T, which is 18. Just plug that in your calculator, and you end up with Q is equal to 240. And the units for Q is joules. All right, this one, it says if 596 joules of heat are removed, this word is very important. What that word is telling us is that it is losing that heat. And so if it is losing heat, that means this is a negative 596 joules. If it were to be absorbing that heat, it would be a positive Q. But in this situation, it's a negative Q because it's losing that heat. And so we're given a mass, and it's saying 29.6 grams of water, and it's starting at 22.9 degrees Celsius. Now, again, we're going to use Q equals mc delta T. We have Q, we have M. The problem does not give us the specific heat of water, but if we look at our chart, we do have the specific heat of water on the chart, and it's 4.18. Wow, that's the amount of joules in 1 calorie. And then delta T, again, delta T is equal to the final temperature minus the initial temperature. We have the initial temperature, and so the question is, what is the final temperature? So that's what we're looking for. And so what we're going to do is we're going to plug this in. And let's go ahead, and before we get started though, what type of final temperature should we have? Well, if we're removing heat energy, that means the temperature is decreasing, so we should have a final temperature that's less than the initial temperature. So let's go ahead and do that. So we have negative 596, that is the heat. The mass is 29.6. The specific heat of water, which we got from the chart, is 4.18, and the chart is in your notes. And then we have the final temperature, which is what we're looking for, minus the initial temperature, which is 22.9. Now, to do this, the first thing I'm going to do is I'm going to condense this a little bit. I'm just going to go ahead and take these and multiply them by each other. And when you do that, you end up with 123.72. So let's go ahead and do that. So we have 123.2.7. And again, that's multiplied by the final temperature minus the initial temperature. And then what we're going to do is we're going to divide both sides by 123.7. And when we do that, this is removed from that side. And then this ends up becoming negative 4.82. And that's going to be equal to the final minus the initial. And all we need to do is add 22.9 on both sides. And this cancels out when you do that. And it's just this part here. And so you end up with this situation, where the final temperature is negative 4.82 plus 22.9. And you end up with 18.08. And with sig figs, it's going to be 18.1 degrees Celsius. And so this is the final temperature. So again, we were looking for the final temperature, and so we just took this expression here and plugged it in there and solved for that using algebra. All right, now we have if 182 kilojoules of heat is required to raise the temperature. So again, this word, what is this word telling us? Is that telling us it's a positive Q or a negative Q? Well, because you're raising the temperature, that means it must be absorbing that energy, which means it's a positive Q. And that's the temperature of a sample of mercury. That is 52 degrees Celsius, and the specific heat. Also, it's raising it by 52 degrees Celsius, so that is the change in temperature. It's giving you the specific heat there, and it's asking for the mass of the mercury. Well, the first thing we have to notice is that this is kilojoules. This happens to be 1,820 joules, all right, because the Q equals mc delta T equation uses joules. Okay, so we will be using Q equals mc delta T. Now we just plug this in. Okay, so we have Q, which is 1820, is equal to the mass, which is what we're looking for. The specific heat is 0.14. The change in temperature is 52 degrees, so we're raising it 52 degrees Celsius. And so all we need to do is do some algebra to solve for the mass. And we end up with this setup here. We just plug that into our calculator. And we end up with a mass of 250 grams. And that's it. This equation is very straightforward. It's very easy. You just take what's given to you and you plug it in. I'll say that maybe number 2 can be a little tricky, but you just got to remember that the change in temperature is the final minus the initial, and you just plug in what you have. That's all that there is for this. Go ahead and do the other practice problems and look at the answer key on the Schoology. All right.